So we're going to take a look at interception for relative velocity between two bodies. So for this one, what we want to do is we want to change everything to be vectors. And if the two bodies are intercepting, then we can use the fact that either their I components or their J components will be the same. So let's take a look in relation to a question then. This is two independent bodies. This is the fifth part of the two independent bodies for relative velocity. So this question here is an ordinary level question. We'll take a look at a higher level kind of type of question in a minute. So this question here, we have ship A is positioned 204 kilometers south of the lighthouse. A is moving at an angle of alpha east of north at a constant speed 58 kilometers per hour, where the tan of alpha is 20/21. Ship B is positioned 510 kilometers due north of lighthouse L, and B is moving east at a constant speed of 40 kilometers. So part one asks us to find the velocity of A. So that's what we're going to do. We're going to get velocity of A in terms of I and J. So part one here. So velocity of A is going to be, we're going to need to be able to find what that angle is. We don't know what that angle is, but we do know that tan of the angle is going to equal 20/21. So if I draw my right angle triangle, I know I have O and A for tan. So if I make this my angle, my O is 20, my A is 21, and I know then that this is going to be 29. So this is O, A, and H, and I just use Pythagoras to do that. So now I can find that sine of the angle is going to be opposite over adjacent, opposite over hypotenuse, so that's going to be 20/29. And the cos of the angle is going to be 21/29. So we can use that fact now. We're looking for this angle in here. Now that is the angle that is going from north to east. So generally we don't go from north to east, generally we go east of north. So for this one, we're going to have to swap our cosine and our sine, and what we're going to end up with is that the velocity of A is going to equal our 58 anyway, 58, but instead of writing cos theta here, we're going to write sine theta, and then we have our I, and then we'll have our 58 cos of theta and our j, and we know we're going in a positive I direction and a positive j direction. So in for this, I can pop in that I know it's 58. In for sine of theta, I know it's 20/29. And then I have 58, and in for cos theta goes 21/29 j. So my V of A is going to be 40I plus 42j, and that is part one done. So for part two then, they ask us to find V of B. So I'll do part two over this side. V of B, nice and simple, is just going along the I plane, so we don't need to worry about the j part. It's going to be a 0, and we're going to just be going 40 kilometers, so it's going to be 40 I and 0 j. Our part three of this then is asking us to find the velocity of A relative to B. So we know that's going to be A subtract B. Now if we look at these are pretty easy because the I's are going to cancel when we subtract them. So it's going to end up being 0I and 42j. Okay, part four of this question then, it's asking us to take a look at the ship A intercepts B after T hours. This is our interception. So it hits ship A, intercepts ship B at T hours, find the value of T. Now what we know from what we've done here is that they're both going 40 kilometers an hour in an east direction. So really we don't need to worry about the easterly direction at all. All we need to take a look at is, well, we know if it's going for A, if A is going 40 east, it's also going 42 north. So that means what we really are looking at here is if I have 204 and 510 kilometers to go, that gives me a total of 714 kilometers that I need to go. I know I'm going 42 kilometers upwards or north every hour, so I'm going to take my 714 and just divide it by 24, and that's using our distance, speed and time. So that time is going to equal the total distance over your speed, and that is giving us 17 hours. So it's going to take 17 hours for them to meet. So if the easterly directions are the same, it makes it a nice bit easier. So the fifth part of this, then it says the distance from the lighthouse to the meeting point, to L, the meeting point. So we know that for 17 hours, they have been going easterly, and that they're going to meet on an easterly point, whatever distance out here. And what we're looking for is how far are they. So we're going to create this right angle triangle. We know we have 510 on this side here. And then to find this length here, all we have to do is we have to say, well, they're going 40 kilometers and they're going that for 17 hours. So they'll end up going 680 kilometers altogether. So my 680 goes up here. And what I'm using then is I'm using Pythagoras' theorem so that I'm finding the hypotenuse. So the hypotenuse is going to be the square root of 680 squared plus 510 squared. And that is going to give us 850 kilometers. And that is our distance from the lighthouse L to the meeting point that they meet at. Okay, so that is an ordinary level kind of standard question. This question here, then you'll end up doing pretty much the same thing for the higher level questions. It's just that they won't tell you as much information. They won't break it down like in this question here. They said find the velocity A, then find the velocity B, then do this, then do that. Whereas this, you'll just have to figure that you have to do all of that on your own. So here we have two objects. Let's say that they're cars or ships again, whichever, and they're going 4 route 10 kilometers per hour. So let's say they're ships. If D intersects C, find the direction of D. So really what we're looking for is we're going to try and look for this angle in here in the middle, because that's going to allow us to find our direction. So what we're going to have to do is we're going to have to find V of C, V of D, find where their I component or their J component is the same, and then that will mean that we're able to solve to find the unknowns. So I'm going to get the velocity of C first. So velocity of C, because that one is quite easy, you have all the information. I'm going to have 4 root 2, because I'm going from an west upwards, a west-north kind of direction, I can use my cos first, 45, and I know that's going to be I, and then I'll have 4 root 2, my sine then of 45 goes with the J. Now it doesn't make any difference because sine and cos of 45 are the same thing. Next thing then, I know my I's are going in a negative direction because they're going to the westerly side, and then my J's are going upwards, so they are positive. So when I pop that into the calculator, I can find that V of C is going to be minus 4I and plus 4J. So there's my V of C. V of D, then my velocity of D is going to be the same thing, 4 root 10, but because I'm looking from for this angle in here, that is going west of north, so that's going to change. That's why I have to put sine in here of this angle that we don't know, and that goes with the I's. And I do the exact same thing for the J's. And then I'm going to check and see my J value is going to be positive, my I value is going to be negative, and I can't do any more with that. So I have V of D and I have V of C. What we're looking to see then is if I know that they're going to intercept, what values are going to be the same. So we have 2 ways we can do this. If I look at the I values, we know that they're starting at the same point, so they're going to have to go this way the same amount. So it's going to be when their I values are the same. Whereas if we were looking at going upwards here, what we would have to say is it's going to be however far C goes plus 16. And that's how you would write this one. You would say that plus 16 should equal the distance that C goes. So you'd have to add in your 16. So I would go with the I way because it's just much easier, because the I's are going to have to be the exact same because they go the same distance to the left to meet each other. So I values are going to be the same. So I'm going to write 1 minus 4I is going to equal minus 4 root 10 sine theta I. We're going to get rid of anything that is in both. So I'm going to get rid of minus 4 and I'm going to get rid of I. So that on the left hand side of the equals is going to leave just the number 1 is equal to root 10 sine theta. I'm going to bring my root 10 over. Okay. So if I'm looking then for this, I'm going to write sine inverse of 1 over root 10, and I'm going to just round that to be 18 degrees. So if that's 18 degrees, this angle in here is 18 degrees. So what you can say then is, if you're looking for a direction, you can say that your direction, generally again we read the directions from our y-axis up or from our west or east side. So you're going, it's 72 degrees then, we take that away from 90, 72 degrees north of west. And that's the direction that is going. If they ask you for the magnitude, then you would say that it's this 4 root 10. And that's that question completed. So that's you using the fact that the I values are going to be the same.